focus is on Azure DevOps. So what is DevOps first of all? So before we try to know about Azure DevOps, we need to understand what is DevOps. So DevOps is a set of practices, tools that combines software development. Software development is abbreviated as Dev, and IT operations, OPS, Ops, okay, to enable faster and more reliable software delivery. So that's DevOps. Okay. So why is DevOps important? So because you can see the list of reasons for DevOps using DevOps. Number one, faster delivery. Okay. So as I already told you, it speeds up software development and deployment. So which is one of the essential um, thing every organization needs, because they need to develop quickly because clients cannot wait for too long, and better collaboration. So they want to integrate all the developers and operations team so that they can coherently develop a consistent application. Automation, so it will actually automate the development process and continuous improvement. So once software is deployed, we can continuously develop feature by feature and deploy it. So and deploy it, we can deliver it. So that's the reason. And finally, higher quality. So because we develop one feature at a time, we can help catch bugs early, and we can improve the software quality. Now let's say there is a let's take a real example. So imagine there is a restaurant kitchen. So now you can compare developers as somebody who actually cook, or you can call them chefs. They are the people who prepare the food. Okay. And that food needs to be served. So then comes the operations team. Okay. They are like people who manage the restaurant or who serve in the restaurant. Okay. They take the food prepared by developers and they serve it to the customers or the clients. So the developers and operations team, they work together to deliver the product to the customer. So the devs and the ops team, they work together. So they coordinate well. If they don't coordinate well, so customers don't receive the orders on time, and eventually that makes customer irritated. So we should never, disappoint the customer. So this is an example of the illustration of DevOps. Okay, so DevOps ensures that they work together smoothly for quick and quality service. Okay, right. So let's see one more idea. So how software was developed before DevOps. So before DevOps, people developed software, and they used a linear process, which is called waterfall model. Okay, and that separates the developers and operations IT team. So that was the approach. So you can see in the graph that there are 4 stages. Of course, there are not 4 stages. There are 4 components. Number one is traditional models. Okay, so they use traditional models where everything is done step by step. Okay, that's waterfall model. So you can see waterfall model has 6 steps. Okay, the first step is they gather the requirements. Okay, generally this is done by an experienced developer or a person with good idea about software. So they will do it, and they gather the requirements from a client. They design the application, and design means they create framework. Then they do development, and finally they test it and they deploy it, and continuously they have to maintain that. So they cannot continuously improve the application. So this is a linear process. There is a starting point and there is an ending point. Once you begin a project, you have to end it at some time. Okay, that's a problem with waterfall method. It is not iterating. So if we use waterfall method, there are advantages and there are disadvantages. Advantages are It is simple and easy to understand. Okay, because we begin with gathering the requirements from the customers, and finally we have to maintain the software. Okay, it is just maintenance. Not only that, so it works well for small projects with fixed requirements. But if the project is very large, so waterfall method is not effective. And what are the cons or problems? So this waterfall method is slow and rigid. No changes allowed once a phase is completed. So if there are actually few phases in this, we are going to see that 6 phases. Okay, of course I'm not going to talk about it in detail, but there are phases. Okay, so once a phase is completed, we cannot go back and we cannot make changes. Okay, that's number one. And testing happens at the end, leading to late bug detection. So testing happens not intermittently whenever a feature is developed, but testing happens at the end of the project. And developers and operation teams work separately, and this also causes delay. So these are the disadvantages. So if you look at this traditional software development, which is you know waterfall method, or you can call it as waterfall model. So if we use this, okay, so what it does is it will separate developers and operations team. So developers write code. You can see in this chart there are developers. There, the developers, let's say they wrote code and they send it to the operations team. Okay, they send it to the operations team for deployment. Okay, operations teams handles infrastructure, monitoring, and maintenance. And they handle the infrastructure, monitoring, and maintenance. And there was minimal communication between both the teams, operations team and the developers team. There is minimal communication. So that's the problem with this. Now, what is the problem with this approach? Okay, so there are several problems. Okay, in this approach, you know, it works on any machine problem. Sorry, it works on my machine problem. So when they develop an application, a developer will say, see, that code broke on your PC. That code didn't work on your PC, but it worked on my PC. So works on my machine problem. Okay, code worked on a developer system but failed in production. So code fails in production, impacting operations heavily. That's number one. And slow deployments. Okay, so operations had to manually configure servers. Operations, that department had to manually configure servers, and that eventually leads to delayed releases. So manual server configuration delay releases, but are infrequent. Okay, but are infrequent. So slow deployments and frequent errors. Bugs were discovered late and required rework. Okay, they required rework, so causing significant rework. So these are the problems. So that's why we need DevOps. So what DevOps does? Okay, to solve these issues, DevOps was introduced to bridge the gap between development and operations. So you have development team on the one end and operations team on the other end. So DevOps will bridge the gap between both. So implement DevOps to enhance collaboration. So introduce DevOps for seamless integration. So that's what DevOps does. Okay, right. Now the question is what DevOps aims to achieve and how it works. Okay, so the number one is what DevOps aims to achieve. So it does 5 things. Okay, so DevOps is designed to solve problems of traditional software development. Traditional software development. The first problem it solves is faster software delivery. Okay, so how does it deliver faster software? Automating processes to release software quickly and efficiently. So it automates the processes to release software quickly and efficiently. That is the first thing. Faster delivery, software delivery. So process automation, efficient release cycles. Okay, these are the two things. Then continuous improvement. Okay, so it ensures frequent updates and bug fixes without delay. So frequent updates and bug fixes without delay. So you can see frequent updates, timely bug fixes. This is the second reason, you know, DevOps tries to achieve. Okay, second thing that DevOps tries to achieve. Third one is better collaboration. You can see better collaboration. So breaking the wall between development and operations team. So development team and operation team can collaborate better, so they can work together. Then high quality software. The fourth one is high quality software. So detecting and fixing bugs early through continuous testing. So we continuously test it and we do early bug detection. So high quality software. That is the fourth reason. And the fifth reason is reliable and stable systems. Automating deployment to reduce human errors. So automated deployment will reduce the error. It will do the error reduction. So these are the reasons, or you can say uh, DevOps achieves these 5 goals. Okay. So now how does DevOps work? You can see the DevOps lifecycle sequence here. How does it work? So DevOps follows a continuous cycle called the DevOps lifecycle. So unlike waterfall model, there is a beginning and there is an end. So it begins with the requirement gathering and ends with maintenance. It is not like that. Okay. Now this pipe starts at 1 and ends at 6, but 1 and 6 are connected. Okay. So it is continuous. So DevOps follows a continuous cycle called the DevOps life cycle, which consists of 6 key stages. You can see the 6 key stages. Number 1, okay, you can see here, plan. Define the project scope, requirements, and goals. In the plan, we define the project scope, requirements, and goals. That is number 1. Number 2, write and update code using best practices. Okay, this is done by developers. Okay, number 3, build and test. Convert code into software and run automated tests. That is a third stage. Fourth stage, release and deploy. Deploy tested code to production environment. Okay. And fifth stage is operate. So maintain software, monitor performance, and ensure reliability. And sixth stage, monitor and feedback. So gather feedback to improve the future versions. And again, okay, this will take you to step 1. So you will go through these 6 steps continuously and repeatedly. So this is called iteration. So this cycle repeats continuously, enabling continuous integration and continuous deployment. Continuous integration CI and continuous deployment CD. Okay. So let's take an example from real life. Imagine an automobile factory. So there is a development team. Okay, now you can assume development team is engineers designing a new car model. Okay, so that is development team. On the other hand, you have factory workers, which is operations team. Factory workers assemble and ship the cars. There are 2 teams. Okay, so DevOps ensures engineers and factory workers collaborate smoothly, so cars are built efficiently, tested properly, and delivered on time. So that's what DevOps does. Okay, they are delivered on time. Now let's talk about Azure DevOps. Azure DevOps. Okay. Now, what is Azure DevOps? Azure DevOps is a set of tools and services provided by Microsoft to help teams plan, deploy, test, and develop, test, and deploy software efficiently. It allows teams to collaborate, automate, and manage the software development lifecycle using DevOps approach. So DevOps, we need DevOps understanding, and we are going to use cloud-based platform, and Microsoft is also involved in it. Okay, right. So Azure DevOps is all about this. Now the question is, why Azure DevOps? Why use Azure DevOps? Okay, that is a question. Okay, uh, let's see. Okay, you can see there are tools and services. Azure DevOps provides comprehensive set of tools and services for software development. Okay, it facilitates collaboration and management throughout the software development lifecycle. Okay, so why use Azure development, Azure DevOps, or benefits of Azure DevOps? Okay, number one, faster software delivery. You can see faster software delivery. So automates CI/CD pipelines for quick deployments. Then efficient project management, tracks tasks, bugs, and features. Collaboration tools helps teams work together smoothly. Fourth one, scalable infrastructure supports both small and large enterprises. Okay, infrastructure is scalable. And finally, and this is favorite of everyone lately, so cloud and on-premise support. You want to host, you want to deploy your application on the cloud, you can do that. But there is also on-premise software, works on Microsoft Cloud or your own servers, your own servers. Okay. Now, what are the key services in DevOps? You can see key services in DevOps. Number one, Azure boards. So what is the purpose of it? Project tracking. As your project progresses, okay, as people begin to work together, you can track the project and you can manage the tasks. So you can see here task management and agile planning. Okay, these are part of Azure boards. Then we have Azure repos, source code management with Git repositories. Source code management with Git repositories. Then we have Azure pipelines. So this is for CI/CD automation for building, testing, and deploying software. Building, testing, and deploying software. So this is Azure pipelines. Azure test plans, automated and manual testing tools. Okay, we can use automated and manual testing tools. Finally, Azure artifacts. Now this is for package management for dependencies. Okay, package management for dependencies like npm, nugget. So we have different dependencies. Okay, now let's see an example for real life. So think of Azure DevOps as an office workspace. Office workspace. Okay, so if you look at it, so Azure boards. Now Azure DevOps is an office workspace. So you can see 5 tools here, okay, or 5 components. Azure boards contains to-do lists and schedules. Azure repos are shared folder for storing and managing documents. Okay, Azure pipelines, automated processes for sending emails and reports. Azure pipelines. And Azure test plans, checking and reviewing the reports for accuracy. And finally, Azure artifacts are storage shelf for commonly used office supplies. Okay, so just think about it. So how do you understand this? First, you'll start with to-do list. Okay, and you need storing and managing documents. Okay, and you need to send emails and reports, and you need to review all reports for accuracy. And finally, a storage shelf for commonly used office supplies. Okay, right. Now let's go to Azure boards. Azure boards. Introduction to Azure boards. Okay, so now we know what is DevOps. Okay, the first key component is Azure boards. Okay, so let's look at the dimensions of the Azure boards, or you can simply say, what is Azure boards? Azure boards is a work tracking system. It is a work tracking system. You want to track the work. Okay, and Azure boards is a work tracking system that helps teams plan, track, and manage their projects using Agile, Scrum, or Kanban methodologies. Agile, Scrum, and Kanban methodologies. It is mainly used to organize tasks, track progress, and collaborate efficiently. That's the purpose of Azure boards. That's number one. Number two, why use Azure boards? So number one is organized workflows. Now helps teams structure their work clearly. So they can clearly structure the work. Second thing, real-time tracking. And it monitors the progress with dashboards and charts. That's the second step. Second, reason. Third reason is better collaboration. Enables team members to assign and update tasks easily. Fourth reason, flexible methods. It supports Agile, Scrum, and Kanban. Fifth reason is integrated with Azure DevOps. It is integrated with Azure DevOps. Okay, so works with repositories, pipelines, and testing. So that's why we use Azure boards. So we want to organize the workflows. Okay, now let's look at the key features. Key features of Azure boards. Okay, Azure has a lot of key features. Okay, so number one, work items. Okay, so what are the work items? Tasks. You can create tasks. Bugs. Working on bugs is an item. Okay, and user stories that need to be tracked. We need to track the tasks, bugs, and user stories. Okay, these are the three things. Okay, work items. Right. Then boards. Boards. Okay, you can see here. So we have Azure boards. Okay, so boards. So what are these boards? They are visual Kanban boards for easy task management. So task management and visual tracking. So you can manage the tasks visually. Okay, you can track them visually. Then we have backlogs, a list of tasks that need to be completed in future. Backlogs. Okay, you can see a list of tasks that need to be completed in future. That is backlogs. Sprints, short cycles of work. Okay, short cycles of work, which is actually Scrum methodology. Okay, so short cycles of work, so you can call it as iterative works. Dashboards, real-time charts and reports for tracking progress. Real-time tracks, charts and reports for tracking that. So let's take one example in real life. Okay, so which is related to Azure boards. Now, so imagine you are managing a restaurant kitchen. Okay, so restaurant kitchen management. Okay, so here, so the first thing is Azure boards equal to Azure boards is the restaurant's order tracking system. Azure boards is restaurant order tracking system. You need a order tracking system. Okay, restaurant order tracking system. That's number one. Okay, so that's number one. Azure boards stands for it. Then comes work item. Okay, so you have to create a work item. Okay, so each customer order is a work item. So it can be burger, pizza, etc. It can be anything. Okay, then third is add to backlog or backlogs, pending orders to be prepared. Okay, pending orders to be prepared, backlogs. Okay, then sprints. Okay, we have sprint and sprint execute. Okay, sprint and sprint execute. sprint a time slot, example 30 minutes to complete multiple orders. Okay, so in 30 minutes you can complete this many orders. Okay, time slot is allocated to complete the orders. Okay, kitchen staff works on to complete the orders, so that is called executing the sprint. Okay, finally boards, a whiteboard showing all orders, who is cooking and what is ready. So a status of each order is updated on the board. So finally it completes the order. So the order is completed and served to the customer. Okay, so this is an example in real life. Okay, so that's good. But now the question is, let's create uh, a new project. But for that you need to create an organization, okay, which we have already created. And we click on Azure boards, we add a work item. So where we'll add a simple thing like develop login page. Okay, that is a work item we are going to add, and we assign it to a user and track its progress. So let's do that. So go to dev.azure.com. So already there is an organization named AI unit, and in that we'll create a new project, and this project we'll call it as you know test project. Okay, and we can write a description. It is private, and we can go to advanced. So version control is good, or you can choose other one. It is a basic. So choose the basic process, work process. So click create. Okay. Now here in this, okay. So we'll under Azure boards. So you can see there are boards. Okay. We can go for work items. Okay. So we can add a work item. So new work item. Okay. A task is you can call it as develop login page. Develop login page. So who is going to do that? Okay, one person. Okay, it will list all the people. So if you want to save it, you can save it. Just save it. Okay, no need to worry about it. So we have assigned it to ourselves, and then we can track its progress. Okay, right. This is the first thing we have created. Okay, now let's look at the repos, Azure repos. Okay, right. So let's see Azure repos. Now, what is Azure repo? Okay, so what is Azure repos? Azure repos is a source code management system. Source code management system. That means your code is managed by repos, just like GitHub. Okay, so it helps developers store their code, just like GitHub, track it, and collaborate on code using Git repositories. Collaborate on code using Git repositories. So it provides a secure and scalable way to manage code for individuals and teams. That's what Azure Repo does. So a source code management system, it uses Git. It provides a secure and scalable way to manage code, whether it is for individuals or whether it is for teams. So you can see source code management, Git repositories, there is a security and scalability. Okay, right. Now next question is, why Azure repos? Why Azure repos? Okay, there are several reasons actually. There are 5 reasons, but here in this picture we see only 4 reasons. Number one, version control. So what is version control? It keeps track of all changes made to the code. Okay, keeps track of all changes made to the code, keeps track of all code changes, ensuring history and accountability. Okay, but simply keeps track of all changes made to the code. That's number one. So it's number one. Number two, collaboration. So allows multiple developers to work on the same project. So enables multiple developers to work simultaneously on projects. Backup and security. Okay, ensures code is safely stored and protected. Safely stores and protects code from loss or unauthorized access. Integration. Work seamlessly with Azure pipelines, boards, and CI/CD. Okay, it works seamlessly with Azure pipelines, boards, and CI/CD. And finally, there is another feature. Another reason for using Azure repos is supports Git. Uses Git for distributed version control. Okay, right. So there are two types of repositories in Azure repos. One is Git. That's what we just now discussed Git. Okay, one is Git. Okay, so types of repositories in Azure repos. One is Git. Okay, so Git repositories, they are distributed version control system. Distributed version control system, Git. So many people can work on their PCs, and once they do their changes, and they can push it to the you know uh, remote repository, and all the work that is pushed to the remote repository, they can pull it to their system. Okay, so this is Git. Okay, distributed version control system. This is recommended. This is recommended. On the other hand, we have TFVC. Okay, Team Foundation Version Control. This is centralized control, version control. Okay, it is an older method. Okay, so centralized control version, it's flexible, it's not flexible, less flexible. People will work on a code base that is common to everyone, which is stored somewhere on the cloud or in the server. Okay, it is central. So most modern projects use Git because it allows multiple developers to work independently and merge their changes efficiently. Okay, they can work independently and merge their changes efficiently. So that is the reason. Okay, let's look at one example. Imagine Google Docs. Okay, so Google Docs. Now we know Azure repos, right? So Google Drive for storing documents. Documents are like your code files. You can imagine like that. Imagine Google Documents and use Google Drive for storing documents. Now your documents are like code or code files, and you store there on the Google Drive. So that Google Drive is like Azure repos. Okay. So developers start collaboration. That is first thing they do. Okay. Then Git tracks all changes made to the documents. Version control. Okay. So it tracks all changes made to the documents. Version control. Okay. Then developers, multiple people editing the same document. Multiple people can edit the same document. Finally, commits and pull requests. Okay, so these two steps, commits and pull requests, saving and reviewing the changes before finalizing them. Before finalizing them. Okay, let's do a small example. Okay, let's create a new project. Already we have a new project. Let's click the Azure repos. In Azure DevOps, we create a new repository. We click new repository and we choose Git. Okay, and we clone the rep to our computer and we can add a file. Okay, so I'm just going to do it part of it. So we have Azure repos, and I just go to this menu in the top, new repository. Okay, it should be Git. Okay, so TFVC is also there. Git, name this. This is the test repository. So let's call it as test repo. Okay, you can add a readme file. Okay, so right click create. So you can see it created a readme file. Okay, all these things. Okay, you can also clone it to your local system. If you want to clone it to your local system, copy this link. We are going to do that sometime. Okay, sometime. Now let's look at another idea. Okay, I know it appears that I am going a little slow, faster. Uh, Charles, you are able to follow?
Yes, sir, it is clear. Now I can able to understand.
Okay, so thank you. So let's go with Azure pipelines. Okay, another concept. Okay, the fourth component, third component. So Azure boards, Azure repos, and Azure pipelines. Okay, so it is the most important component. Azure pipelines is the most important component. Now the question is, what is Azure pipelines? Azure pipelines is a continuous integration and continuous deployment CI/CD tool. The pipeline is the CI/CD tool that automates the process of building, testing, and deploying code. Okay, it will automate building, testing, and deploying code. It ensures that software updates are released quickly, reliably, with minimal errors. Quickly, reliably, and minimal errors. Okay, so why use Azure pipelines? There are several reasons, but we specified the 5 reasons. Number one, automate software deployment. Okay, so it reduces manual effort and speeds up releases. Automate software deployment. Okay, manual efforts are reduced, and eventually, things will go faster. Then continuous integration. Okay, so automatically tests and merges new code changes automatically. Continuous integration. Then continuous deployment. Okay, deploys tested code to production environments. Deploys tested code to production environment. And then works with any language. It supports Python, Java, JavaScript, .NET, and many more languages. Okay, and finally, cloud and on-premise support. Cloud and on-premise support deploys to Azure, AWS, Google Cloud, or local servers. Okay, right. Now, how Azure pipelines work? That is another thing we should focus on. Okay, right. First thing is code commit. Developers push code to Azure repositories. So just now we saw repos. Repos are just like Google Drive. So you make changes on your local PC and you push it to Google Drive. So in the same way, people commit. They developers they make changes to code files or they create new code files. They push code to Azure repositories or Azure directories. Okay, that's number one. Okay, and after that, okay, code commit. We have build stage. Okay, Azure pipelines compiles and packages the code. Compiles and packages the code. Okay, so it compiles the code and packages the code. After that, we have test stage. So runs automated tests to catch errors. That is test stage. Okay, and then we have release and deploy stage. Deploys tested code to staging or production. And finally, monitor and feedback. Tracks performance and errors for improvement. Okay, this is Azure pipelines workflow. Okay, so let's take an example from real life. For example, imagine a pizza delivery service. There is a pizza delivery service. Imagine that. So Azure pipelines equal to kitchen's automated process. In the kitchen, there is an automated process. Modern day kitchens, especially cloud kitchens, and there are big restaurants. They automated a lot of things. So imagine a pizza delivery service. So Azure pipelines is like kitchen automation process. Okay, automation process. So Azure pipeline is automated process. So kitchen automated process prepares ingredients. Then continuous integration ensures the recipe code is correct before cooking. Okay, so ensures the recipe or code is correct before cooking. Continuous deployment, CD, automatically delivers fresh pizzas to customers. Okay, and finally testing ensures the pizza is properly baked before sending it out. Okay, before sending it out. That is testing. Okay, now we cannot create a pipeline immediately now, but I'll tell you how to do it. So, but let's go to Azure DevOps. Okay, so we have pipelines here. So you can see pipelines. Okay, hover the mouse, you can create new pipelines, create a new pipeline. Okay, so and we can choose Azure repos git here. Okay, if you have code in Azure repos, choose this. Okay, right. So now we need to select a build template. Okay, so there is a test project here. Test repo. So we can select a lot of things here. There are a lot of things. Okay, there is a build template. I'll take Python. Yeah, Python. Python. There are three Pythons actually. Python Django. Okay, review your pipeline YAML. So this is your YAML pipeline. Okay, so now we can automatically build and test it. So run and save. So set up CI with Azure pipelines. We are going to see this. Save and run. Save and run. Right. So let's see what happens. It is job is queued. So let's see whether it runs it or not. Okay. So no hosted parallelism has been purchased or granted. So we need, as I told you, we cannot run it. Okay, because we didn't buy anything. Okay, we will buy. So it tested on Python 3.8, 3.9, 3.10. So we are going to see all these jobs. Okay, the same thing you find on GitHub actions. Okay, which is there it is called actions. Okay, workflow. So same thing we call it here as pipelines. Okay, that is the difference. Right. So I'll stop it here. And if you have any questions, you can ask any question. It can be significant or insignificant. You can ask any